Hello, my name is Sam. I've been helping RoboMindTech for a long time, since the beginning. In that time, I've helped design and teach lessons, and I've helped coach the various robotics competitions teams. The curriculum here involves building a wide variety of different machines, mechanisms, programming robots, depending on your age. So we believe that, like any good school curriculum, learning these kinds of things, these mechanics, is a cumulative process. And from my own studies, it's always good to get the big picture first before you start to fill in the details. For the younger kids, we tend to go for these beautiful models that are very simple, really highlight the way the mechanism works. For early childhood, we use the big blocks, which are just, I think, some of our really amazing concept models, because it's just like a big gear and a small gear and this big turning thing. And even if you're 4, you can understand where the force is going, how that works. If you are 7, 8, 9, 10, you go into our technical creation discovery series. And these are more of the Lego Technic models. And something that I always enjoyed about Lego Technic is that you can build kind of anything you want out of Lego Technic. There's an analog for most real-world machine pieces there. You have axles, gears, big structural pieces. And if you want something more complex, you can always create it out of some combination of these simpler pieces. An interesting thing that they often don't have experience with is getting it to behave the right way. So a lot of the technical creation discovery models focus on, how well do your expectations of your model really match the reality? Does this behave the way you want it to? How do you test the model? Do you understand the underlying things at work? Do you know why this is sturdy, why this is not sturdy, why this is going faster or slower? Do you know where the force is coming from and where the force is going? So these kinds of intuitions that really need something physical to touch and hold and play with to get that in your head. If you are 10, 11, 12, we have our robotics series of lessons, which is a different beast altogether. So the technical series is really about machines and forces and structures. Robotics is about how to make the machines think and what that means. So there are a lot of limitations with just a straightforward machine. It will only do the same thing over and over. But what robotics allows you to do is it lets you put a layer of decision-making, reactivity on top of this machine. So this is starting to become more and more important as we are able to make computers smaller and smaller. There's computers in almost everything nowadays. And it allows you to really explore not only the kinds of technical, mechanical concepts that you see in a discovery level class, but also you get the additional programming level of, how should it behave in this scenario? What should it do with this set of inputs? And it teaches both, prototyping, design, iteration, and also this algorithmic thinking. There is this sense of allowing the kids to do the experimenting, allowing the kids to do the work, and then you're there to guide them, help them recover from mistakes, tell them if something is a good idea and if it's not a good idea, showing them why. So the way these classes are laid out is we try our best to ground the sort of technical engineering thing in a real-world object. So this is nothing new. Kids connect very well to a concept if they understand how it is immediately applicable. It's why play is so powerful, right? Kids will imitate what their parents are doing. They will try to understand what the adults around them are doing. And it's an entirely beneficial thing to try to ground what you're trying to teach them in something that they see every day or something they might understand. And then there's this build step where they do a guided build from instructions to build the base, the core of the model. And then once you've built it, there's the extension phase, the exploration phase, where, now it exists, and now it's basically a toy, right? It's a cool toy that you could have bought at the store that you get to play with. But it's different because you built it, so you know exactly how it works, you know exactly what all the pieces are doing, why things are the way they are, and even better, you can change it. So we can ask a question like, what if this was longer? What if this was heavier? I think that's really what we're trying to do. We're just trying to make this entire process fun and engaging and just almost not tedious, right? It's just very fun to come here and do this. Even for me, I'm still learning every day.